Good afternoon. Thursday, February 14th, noon to 1, Math 123. Welcome to class. And hey, happy Valentine's Day too, I guess. I don't know. Make sure you tell someone that you love them today, okay? Doesn't matter who it is. All right. So what I want to do is just let you know, as I read through the submissions for the pie graph or the pie chart, I have to let you know about disappointments. I don't remember if they were from this class or my other class. I'm just making a general statement here. But I want you to know that at this point, when you are asked to answer questions, and like I think one of the questions said, describe at least two things, that you notice about the graphs. You have to be a little more quantitative at this point. Like, you can't say, well, this group is bigger than this group, because that's too basic for you guys. You could say something like, if you add these two groups together, it's about the same as this third group over here. Okay, so you want to be a little more descriptive. You want to be quantitative. Okay, because I think a lot of the answers I got were pretty basic and didn't really show me that you put any effort into it. So I want to make sure that, when you're writing your sentences, especially on your exam too coming up, and on your descriptive statistics, if you haven't turned that in yet, make sure that if you have anything to write, that you're doing a good job and you're actually putting some thought into it, okay? Because I've been doing this for a long time and I can tell when no thought has been put into it. Okay, so all right. So I posted a review on the website for you on your Canvas, and that review, let's see, I'm gonna pull it up here. This is the wrong class. Hang on a second. So in your class, we have the exam review quiz that's online, and then in the learning activities, I put in there an extra review practice. It's a paper one, and then I included the key also, so you have that to use to study. Okay, the one I have up on the screen is pretty close to that one. It's a little bit different because I want to give you a variety of questions here. And so here's what I have. I have these few questions. I think there's like 20 questions I have up here, and we'll go through whatever we want to go through today. So I want to leave this up to you. I don't want this to be, it's not a review for me. I can already get 100% on the exam. Aren't you glad to know that? But it's a review for you. And so what I want to do is just have you guide the review. So if you have questions on any of the problems you see on the screen or something you remember, ask, okay? So what I want to ask first is, are there any questions on numbers 1, 2, or 3 that you see on the screen? So take a look at those, see if you can, if you think you can do them. And as a matter of fact, I'm going to start us off by doing number 1A. So this ratio, it says reduce to lowest terms. So, we can divide these by 4, I guess. That's reducing. And then it would be 1/3. So when you answer the questions on your exam, make sure that you put them in lowest terms like that. On number 2, 4 hours to 40 minutes. Well, 4 hours is 4 times 60 minutes. We always want to go into the smaller unit of time when we are comparing two different times. So 240 minutes to 40 minutes. And we can obviously divide each of those by 40. Well, we can divide them by 10. Let's just do that first. And then does 24 go into 24? Or does 4 go into 24? Let's see. Divide them both by 2, we get 12 and 2. So 6 to 1. So that's how you can reduce the ratios. But you want to make sure that you convert so you have the same unit of time or the same unit of distance if you have distance. And then the scientific notation, remember, only one non-zero digit to the left of the decimal. And then the power is how many places do you move to get there? 3, 6, 7, 8 it looks like, so 10 to the 8th power. So those large numbers have positive exponents. And then when you put this in, I think you'd have to put it in like this, 1.496 x 10 caret 8. That might be how you put it in, I don't remember. Unless there's spaces, like there might be a space for each of these, just put the number in. But if you have to type it out, don't leave any spaces. Don't leave a space there, don't leave a space there. Okay, no spaces in between anything. And then if you have a low number like number 4 here, this one is going to be 7.5 times 10 to the, and it's a negative exponent, so these small decimal numbers get negative exponents. So 1, 2, 3, 4, 5, 6, 7, 8. So this is to the negative 8th power. So questions on 6, 7, or 8, you tell me. Also, as you're looking at those 3 problems, I want to say, try, when you come to class, if you were on campus, you probably wouldn't be running into class like at 12:01 or 12:02. So what I'm going to ask is that you try to get here before noon, even if it's a couple minutes before noon, 3 minutes before noon. That would be awesome, because then my attendance can be done when we can start class at noon instead of starting it at 4 after, okay? Because that wastes everybody's time, and we don't want to do that as we move forward. And thank you if you were here before I was here, because I got in here at about 5 till. All right, so it looks like there are nobody has any questions on these 3 problems. All right, I'm going to skip them and move on. So let's look at number 9. Write the following as a decimal, then as a percent. So the way we write this as a decimal is we actually divide it, 7 divided by 8, or on your calculator, 7 divided by 8, and you would get 0.875. So there's the decimal, and then to write it as a percent, we move the decimal 2 places to the right, so it'd be 87.5%. Okay, so that's how you do that. And when you solve a proportion, how do you solve these proportions? What would you do? What is the process? Solve for x, yes, that's what we're going to do, but how do you do that? That's what I want to know. All right, so we can multiply diagonally. So let's do the top one. So we would multiply the 2 numbers that are diagonal, 120, and then divide by the number that's diagonal from the x, divided by 40. So x is 3 in that case. Yep, so multiply the 2 diagonal ones and then divide by the one that's diagonal to the variable. Let's look at 11 and 12. Questions on 11 or 12? All right, looks like it's unanimous that number 12 is the one you guys want to look at. Let me just tell you about number 11. We would take 1.7 million, so 1.7 times 10 to the 6th. And then we would take that times, I'm going to say 5.6 times 10 to the 4th. So this is a multiply problem. And remember, we're going to multiply the 1.7 and the 5.6, and then we're going to add the exponents. So let me just do that real quick. 1.7 times 5.6 is 9.52. So I'm going to go with 9.5 since there's only two digits that are significant. 9.5 times 10 to the, and we're going to add the exponents. 6 plus 4 is 10. So on number 12, it says 4 out of 5 students made it to class on Monday. If there are 7,500 students enrolled, how many made it to class? So 4 out of 5. So the total is like the 5, 4 out of 5. We want to know how many out of the total. So this is the total. We want to know how many out of the total if it was the same ratio, 4 to 5. So we would again multiply diagonally. 4 times 7,500 is 30,000. Divided by 5. And you all are right. 6,000 students made it to class. Perfect. All right, so I'm going to give you a minute here to look at these questions, numbers 13 through 16, and see if you have any questions on them. But let me give you about 2 minutes to look through those, okay? All right. So it's funny how things work out. A really good friend of mine passed away yesterday, and having the funeral in a couple days, and now my niece is having her first child. So I guess some come and some go. That's the way life rolls. All right. So let's take a look at this. Number 13, it says, is this part to part or part to whole? This males under 15 to females under 15. What do you think? Part to part, yeah. Very good. So it says calculate the ratio of males 15 to 20 to the total male population and write a meaningful sentence. So let's just look at that. So males 15 to 20, let me grab my calculator here again. So we have to add up the males here and here, and then compare that to the total. So 6570 plus 6377. So thank you, Brian. 12,947. And we're going to divide that. We're going to make a ratio, right, to the total population, the total male population. So these are males 15 to 20 divided by the total male population, 150,643. Now remember, these are all in millions, so this is all in thousands, so this is really 12 million and 150 million. So if we divide those, divided by 150,643, I get 0.0859. Oh, Brian, you've divided upside down, I think. All right, so in your calculator, always put the top number in first. All right, so we want to write a meaningful sentence with this ratio. And so since it's a part to whole, this one is part to whole. It's part of the male population to the whole population, the whole male population. So what can we do with part to whole ratios? What's the special thing we can do with them? With the answer. What's the special thing we can do with that answer? Yeah, we can write it as a percent. Thank you, Atul. So we can write this as, let's just make it 9%. Yeah. So that's approximately 9%, or 8.6, whatever you want to do with that. So our meaningful sentence could be something like 9% of the male, about 9% of the male population is between the ages of 15 and 20. That would be how our meaningful sentence would be written. We could say about 9% of the male population is between the ages of 15 and 20. So the child dependency ratio, remember, is the under 15 to this middle group, the working group. And it's a part-to-part ratio. So the child dependency ratio is going to be the under 15. So let's just do it here. 62,155 divided by, and we need that, let's see, those four numbers added together. And I think it is, let's see, 10, let's see, 6. I have to put in my calculator. 12,761 plus 12,515 plus 98,562 plus 80,939. 204,777. So when we divide those, 62,155 divided by 204 0.777. I guess something like 0.304. And now it says interpret what this means. And for some reason, these values here don't actually add up to this one here. I think it's 1 off, which is like 1,000 people off. Okay, so 0.304, that means, so the interpretation would be something like each worker has to support 0.3 children besides themselves. Or we could say every 100 workers support about 30 children besides themselves. Well, we can't make this a percent because this is a part-to-part ratio. So we can't say 30.4% of the population is age dependent. And this is just the child dependency ratio. So we can't turn the age dependency ratios into percents because these are all part-to-part. This one we could because it was to the total population. So the child dependency ratio tells us how many children each worker has to support besides themselves. So the age dependency ratio, now that one it's the over 65 and the under 15. So there are 3 dependency ratios we have. The child dependency ratio, which is the under 15 to the middle group. The old age dependency ratio, which is the 65 and over to the middle group. And then the age dependency ratio, which is the under 15 and the 65 and older together to the middle group. So I'm going to take the 62,155 plus 39,179 for the age dependency ratio and divide it by that middle group again. And this will be the age dependency ratio. So 101,334 divided by 204,777 0.49, and then that's going to be a 5. So we can say about half the population is age dependent. Or excuse me, we can't say that. We can say each worker needs to support about a half a person. So 2 workers to 1 dependent. That's the ratio, 2 to 1, 50%. So we can say it takes 2 workers to support 1 dependent person, whether it be an old age or a child. So remember that the child dependency ratio plus the old age dependency ratio equal the age dependency ratio. So that means for us that 495 minus 304, that means that the old age dependency ratio would be 0.191. So these two together give us this one, if you were finding them out in that order. So if you did the work to find the child dependency ratio and you did the work to find the old age dependency ratio, you just add those together to get the whole age dependency ratio. All right, so let's take a look at 17 to 21 and see what questions you have. So hopefully you remember these ratios. This is how we set these up. All right, so Grace is asking for 17. Let's look at 17. It says 13.8% of the U.S. population was under 10 years of age. If the population was 301.6 or 306.1 million, how many people were under 10 years of age? So on that one, we're looking at 306.1 million. That's the total, and we're trying to find out the group, the smaller total, the part. We know that the whole population is 100%, and the population that is the smaller group is 13.8%. So since I didn't put the 306.1 actually into millions, when we get our answer, we'll get the number of millions. So we would take this and do 306.1 times 13.8, divide that by 100, and that gives us the number of millions. So it would be 42.2 million under 10 years of age. And so when you get this answer, you want to make sure that you don't put 42.2, because that's not how many people there are. There are 42.2 million. So there's number 17. What else? All right, so I guess what I'll do is I'm going to actually set 19, 20, and 21 up. I'm not going to do them. I'm just going to set them up. Oh, I'll do number 20, but I'll set these three up. So number 19, it says what is of 90. So X is in the is spot, 90 is in the of spot. The percent always goes over 100. So that's how we'd set this one up. Number 21, 73 is of 243. And it says what percent? We don't know the percent. And then number 20, let's do that one. It says 210 is 25% of what numbers? We don't know the of part. And so we would just multiply, and it is 840, yes. For number 20. Multiply 210 times 100 and divide by 25. That's what we do. All right, so let me just see how many I have left. I have 40 problems, and we are at 22. So questions here. So these 22, 23, and 24 are really just like the ones above them. like number 23, he pays $484 in taxes. His income, the total is 2200. We want to know what percent is taken out in taxes. And then, of course, cross multiply and divide. That's how we do all these. So let me show you down here these per capita problems. So we have per capita and CPI. I think I want to make sure we look at here. So per capita would be well, okay, so Anna's question is how much labeling do we need to do? Usually in Canvas, it's just going to ask you for a numeric answer. So it doesn't like numbers and words all in the same response unless it's an open-ended one. So you have three types of questions. One type of question will be multiple choice, multiple guess if you don't study very well. The second type will be like a short answer, like do this calculation and put your answer in. The third type will be write some sentences. Tell me about this situation. How did you solve this? Okay, so it'd be explaining. Oh, don't forget, and for your exam, you need a government issued ID. So it can't be like your student ID doesn't work at the testing centers, or for ProctorU, it has to be like a driver's license or something like that. Maybe it's your passport or something. Okay. All right. So let's look at this deer vehicle collisions. So I'm not going to do that whole table, but I'm going to show you how we work the table. So we're going to take 51,627 and divide by the 8,373,969. So when I divide this and I get per capita, because per capita means per person, so the deer vehicle collisions here, per divided by the number of people. So I got 0.0061, and then I got a 65. All right. And so that's the deer vehicle collisions per capita. Now, a lot of times we want to do this per 100,000 people, because if I think about this, this is 6/1000ths of a person, or 6/1000ths of a collision per person. Actually, that's what it says. So 6/1000ths of a collision per person doesn't make a whole lot of sense, because we can't really wrap our head around that. And so what we do is we find the collisions per 100,000 so we can actually have a number that we can think about. So if we want the per 100,000, we take this answer that we just got and we multiply it by 100,000. Or we move the decimal 5 places to the right. So I can think about this. So for every 100,000 licensed drivers, there were 616.5 deer vehicle collisions. That makes more sense than 0.006 for each driver. So you have to be careful. So Melissa is making a statement there. You've got to be careful and just make sure that you look at the numbers. Sometimes it might say millions and billions. And so if one says million and the other says billions, you've got to make that adjustment. But here they're just the straight numbers. Oh yeah, you don't want to put percents on these, because these are just, when it says per capita, it just wants a per person. So it's not a percent. So let's see, we can't answer this question without all the values, and I don't have all of them. I don't know if we have time to do all of them. And so this explanation, I really just did that with Illinois. So the explanation for Illinois is there are about 616.5 deer vehicle collisions per 100,000 people in Illinois. So let's look at number 28, because that's a special problem too. So 28 says, if the rate for Ohio is the same as North Dakota, or we're making a statement that Ohio is the same as North Dakota, if there are 483,000 people in North Dakota, how many deer vehicle collisions would they expect to have? So we have to look at the Ohio numbers. So Ohio, 67,699 out of their 7,963,372 people. And we're going to compare that to North Dakota. And all we know about North Dakota is the number of people. We're trying to find the number of collisions that we would expect. And so we're going to take, and we're going to multiply diagonally. 67,699 times 483,000. Then we're going to take that answer and divide it by that 7,963,372. And I got 4,106. So the interpretation would be, if North Dakota's deer vehicle rate was the same as Ohio's, North Dakota could expect to have 4,106 deer vehicle collisions. That would be how we would interpret that. Okay, so I'm going to spend just a minute on the CPI, and then we'll look at these weighted averages. Okay, so explain how you convert decimal from millions to billions or millions to trillions. Okay, so let me take care of that for Melissa real quick. So if I have 18 million, that would be 18 times 10 to the 6th, and correctly it would be 1.8 times 10 to the 7th. Billion would be 18 times 10 to the 9th. 1.8 times 10 to the 10th would be the correct way to write it. And then trillion is times 10 to the 12th. So I don't know that we would convert something from millions into billions, or from we wouldn't really convert, I don't think, millions into trillions or millions into billions. We just need to know how to write them correctly. And then we can do our calculations. But I guess if we were going to move the decimal, like if I had 384 million, it would look like this. And if I want to know how many, if I wanted to know how many billions that is, it would be 0.384 billion. I don't know why we would ask that question. All right, so I don't know, was that helpful at all? Did that answer your question, Melissa? Okay. All right, so let's look at this. Let's look at number 29. It's this CPI question. So they bought their home in 1972 for $14,500, and we want to know if it says its value kept up with inflation. What is the value of the home in 2012? So 14,500, and we're not going to put that over 1972. We're going to put over the CPI for 1972. We're going to find the value in 2012, so we need the CPI for 2012, 229.594. Okay, and we're going to try and find the home's value if it kept up with inflation. So we're going to multiply diagonally and then divide. That seems to be the general theme here. So when I multiplied and divided by the 41.8, I got $79,643.85. So if they purchased their home in 1972 for $14,500, it would be worth about almost $80,000 today, if it kept up with inflation, or not today, but in 2012. That's if it kept up with inflation. If the house actually sold for, let's say, $92,000 in 2012, then the price would have outpaced inflation. If the actual value is more than what we calculate, then the value has outpaced inflation. If it did not, if it was less than, if the actual value, so here's how you make statements about these things. If the actual value was only $62,000, then it was not keeping up with inflation, because the inflation one is the one that we calculate. Okay, so the calculated one was 79,000. If the actual value was 62,000, it would not have been keeping up with inflation. So let's look at these. And that's what this question is going to be like right here. So we want to make sure we do number 40 before we get out of here today. And let's see, the mean, the median, and mode. Let me just talk to you about that for a second. The mean is the average, so you add all the numbers together and divide by how many there are. The median, you have to list the numbers from least to greatest. So like these numbers are not listed from least to greatest, so then you have to do that first. So we list them as 8, 10, 12, 12, 16, 18, and 25. So that's the first thing we'd have to do if we were going to find the median. And then there are 1, 2, 3, 4, 5, 6, 7 numbers. So the middle number is the median, 12. And the mode is also 12. All right, so the mean, we would have to just add all those up and then divide by 7. Let's look at these two different methods of calculating a weighted average. So the first one, we're going to take the number of credits times the point value of the grade. So 8, 16, 6, and 3. We're going to get that total. And we're going to get the total number of credits attempted. So 8, 12. And we would take 33, so the total points divided by the total credits. So it's multiply, add, and then divide. That's the process. 33 divided by 12 would be a 2.75 GPA. Which is like a C+, maybe a B-, depending. All right, so the second method we have is when we have the weights given as a percentage and we're looking for a final percentage. So this method, we would do 75 times 0.15, 70 times 0.2, 80 times 0.2, and 82 times 0.45. So we're going to multiply each of those. We're actually dividing these by 100, so that the process is divide those by 100, make them a decimal, multiply, and then add. So 82 times 0.45. So we can find their percentage in the class. So 78.15%. All right, so let's see here. I don't know what happened here, but the numbers are 34, then 36, then 39. I'm not sure who put this together. I think I know who put this together, but I guess there are more problems on the paper one than there are on here. This is just getting some of the questions. So looking at number 36 on the screen, we have 15 gold necklaces, and they're $110 each, plus 9 silver necklaces at $8 each, plus 10 plated necklaces at $50 each, plus 30 beaded necklaces at $15 each. What is the average value? We have to take all those answers and divide it by all of the items. So whatever that total is, 15, 24, 34, 64. So we take all those answers, all those products added together and divide by the number of items, 64, to get the average for this problem. The next question we want to look at, because it asks about skew, I want you to remember that a graph that is skewed left looks like that. A graph that is skewed right looks like that one. And then a graph or data that is symmetrical looks like this. And the way we tell the difference is on the skewed left, the mean, I'm going to say the average, is less than the median. So the middle number is higher than the average number. And that's because there's an outlier somewhere out here. For the skewed right, the outlier is somewhere out here, so the average is actually greater than the median or the middle number. And then when it's symmetric, the median and the mean, the median and the average are the same. So number 39 says, the New York Times is usually read by older adults. If you were to create a graph of their readers, would it be symmetric, skewed left, or skewed right? So you tell me. So look at the graphs I have. Skewed left is this one. Age is like 0 to 100. Same on this one. Age 0, 100. 0, 100. So I see both left and right here, and I see Brian changed his answer. Okay. And all right, so some people say left, some say right. How do we know? Can someone explain why they chose which one they chose? And then we'll decide which one is correct. Nobody wants to explain that. Well, it is the skewed left because more people are on the right side, excuse me. More old people are on the right side. So there's only a few young people reading the New York Times. Most of them are older people reading a newspaper at this point. So the outlier side is where the skew is. So let me draw that again. So there are only a few young people reading the paper, 5 years old, 10 years old, right? Most of the people reading the New York Times are going to be, let's say, 40 to 65. So since most of the group is out here, the tail is where the skew is. So this is skewed left because the left side is where the outliers are. Okay, the left side is where the people who normally don't belong in this group are located. So that's where the skew is. All right, so the last one, this one says, has minimum wage increased more or less than the rate of inflation? I kind of talked about that a little bit earlier, But this says provide at least 2 calculations to support your answer. State your findings in complete and meaningful sentences. So let's look at this minimum wage. And I'm going to look at 1972 to 1992. So $1.25, 41.8. And then let's see, let's predict what it would be in 1992. Whoops, that's the wrong thing there. So what we're doing is we're showing calculations to see if the minimum wage is increasing faster or slower than inflation. So let's see what we get when we calculate the minimum wage for 1992 based on 1972. We're going to do 1.25 times 140.3 divided by 41.8. So I got $4.20. So that shows that since my calculated value is higher than the actual value, that means it is less than inflation. So let's do another one. Let's do 1972 again and check 2012. So this was 1972 versus 1992. This is going to be 1972 versus 2012. So 2012 is 229.594. And we're going to calculate what it would be if it were keeping up with inflation. And so we have 1.25 times 229.594 divided by that 41.8. So 1.25 times 229.594 divided by 41.8. And I got $6.87. And I have a problem now because one of them is less than inflation and the other one is higher than inflation. So I can't make a determination at this point. I have to do one more calculation. Sorry about that. So let's do 1992 to 2012, and then we'll be able to make a determination. Whoops, I don't want my... All right, because we got to end this here. So 1992, 140.3, 335, 2012, 229.594, and then we're going to see how it works out. So let's try that. So I have 335 times 229.594 divided by 140.3, and I got 548. So since I have two calculations here that show that the inflation amount is less than the actual, so this is the actual, these two calculations right here, with their values, 548 and 687, both show, so we have to make some kind of a statement, right? Based on inflation from 1972 to 2012 and 1992 to 2012, the minimum wage at $7.25 is higher than it would be if it were keeping up with inflation between either of those 2 years, 1972 to 2012 and 1992 to 2012.